Hello everyone. Let's discuss the test paper first. And the first question we need to discuss is question number 6. Question number 6 is body moves along an uneven horizontal road surface with constant speed at all points. Normal reaction of the road on the body is. This is question number 6. We are being given a road like this. That's the shape of the road. An object is moving with constant speed v. This is the road. An object is moving like this. And throughout speed is constant. There are 3 positions: position A, position B, and position C. Question says normal reaction of the body is maximum at A, maximum at B, minimum at C, same at every place. Look at how to handle a question like this. When this object moves, let's say it arrives over here. This is the object shown in blue. And when object is at this position, B, what is the difference between this and this? Right here, mg acting on the body is downwards. Normal reaction is acting up. At this place, mg is down. Normal reaction is up. And when it will be over here, same thing as position A, downward mg, and this is the normal reaction. What is this? That's your this is the object which is moving like this. Right here, this is the shape of the road. So mg is acting downwards, but normal reaction will act towards the body. So normal reaction is acting towards the body, towards the body, towards the body. Whether the shape is this or is this, road is going to push up. Because normal reaction is what? Is a pushing force. So it doesn't matter you have a curvature like this, let's call it convex, or you have a concave surface, normal reaction is acting up. But then what is the difference? If object is over here, then it is describing a circular motion. The shape is circular. circular. If this is the circular shape, then right here will be the center. It will be somewhere here, but just so that you can see it clearly, I have shown the center right at this position. So this place, this is the center of the curved road. And this object is moving with V. At A, what is centripetal force? There are two forces acting, N and mg. But when I say centripetal, it means what? Net force should be towards the center. This is the center. So N minus mg will give you what? mv square upon r. Let's call it normal reaction at A, radius of curvature at A. Look at this C point. This is same as the first one, and therefore at C you can write NC minus mg equals to mv square upon r, radius of curvature over here. But at B there is a change. What is the change? Look at this. Since it's a convex shape, this is the shape, center will be somewhere here. So this is the location of center for this curved portion. If this is the center, then you need centripetal force. So what is net force? That net force first of all should be towards the center. That means this time mg is the dominating force, and you will write mg minus n, which is mv square upon radius of curvature at position B. This C is for center. This C is for center. This C is for position C. So don't get confused with these things. This is normal reaction at point B. Now, question is asking us to compare these values at different points. From this you can see that normal reaction is coming what? mg plus mv square upon r. Shift. For this, normal reaction is coming mg minus mv square upon r. This is normal reaction for position B. This is normal reaction for A and C points. mg is same, V is same, the only change is in the R. What is the change in R? Look at the shape. This is much more flat. At this place, shape is like this. At this place, shape of the road is like this. This tells you what? It tells you that radius A, radius of curvature at A and radius of curvature at C, they are related like this. For this road, radius of curvature is large as compared to radius of curvature for this curve of the road. That means if I increase R, This relation tells me that n will decrease. Rn, which means normal reaction at A and normal reaction at C. How do you relate them? Since RC is greater than RA, NA will be greater than NC. This is first observation. NA is greater than NC. And then look here, Mg minus. This is what? Mg plus. Mg plus. Whether you are at C, whether you are at A, it doesn't matter. You're always adding mv square upon r, this term, into what? Mg. Whereas for this point, normal reaction is what? Mg minus mv square upon r. And therefore the answer for the question is, first of all, they're asking which place the normal reaction of the rod on the body is. First option says maximum at A, which you can see, maximum. Second option says maximum at B. No. B, you can see normal reaction is what? Minus. You're decreasing the term of mv square upon r. And the last option says they are same at all the points. The correct answer is what? Na is the maximum. Normal reaction is maximum at A. Is there anyone who could solve this question? Okay, 3-4 people could answer this. Well, the question is basically related to feeling part. This is the maths behind A, B, C normal reaction. But if you have some intuition, then you can answer the question without writing all this maths. What is the intuition part? Imagine you are sliding down this curved road. There is a frictionless track and you are sliding down. It's a slide basically in this shape. So when you are at this position and you are at this position, let's compare these two first. We'll talk about it later. Feeling part. Right here, when you make a curve, when you make a circular turn, the circular turn requires what? Centripetal force. This centripetal force should be towards the center. The name says centripetal. But mg is acting in the opposite direction. Which means what? What is centripetal force? mv square upon r. Let's say everywhere radius is same. Suppose if you say radius is same mv square upon r, then this term mv square upon r, let's take it as 50. So I told you that to make a circular turn anywhere, you need a centripetal force of 50. Centripetal means towards the center. But what is the direction of mg? Away from the center. Which is like, I want you to have 50 rupees. So if I want you to have 50, but you already have minus of 10, mg is acting down. Centripetal is this. So centripetal force says you should have 50, but you have minus 10. Then how much additional should be provided? So if you have minus 10, but you want 50, then I should give you what? 60. That's the normal reaction. That's the normal reaction. But look at this position. What is happening at this position? You need what? You need a centripetal force of, again, as I told you, 50. Assuming radius is same for the time being. If you need a centripetal force of 50, mg, which was 10, is already towards the center. Which means what? You have to have a force of 50, but you already have 10. That means to have 50, I just need to give you how much? 40. So, normal reaction at this place will be always less than this place. The moment you realize this, you know that this is the maximum normal reaction position. Then you have to compare this and this. How do you compare these 2 points? This place, you can assume as if it's almost a flat surface. If it's a flat surface, then it's kind that we don't need any centripetal force, or the trick part, feeling part. If it's almost flat, you don't need any centripetal force. You don't need any centripetal force, but in this case, since you are making a sharp turn, you need to have the force. So you need to have the force, centripetal force. That means you have minus 10 and I need to give you something to make it positive. In this, you are having negative number and I'm not asking you to have anything. If you are having negative number, just keep it that way. Because almost flat surface, there is no demand of centripetal force. You are happy with the negative amount. And therefore, normal reaction will be definitely less than this. Again, this intuition, this mathematical reasoning, it again involves mathematical terms. And the last, which is the complete feeling part, if you have ever done this type of sliding, then you know that this is the place where you will feel maximum force. If you have ever done this type of sliding movement, not on a road, but in any other place, in a water slide or something like that, you must have experienced that this is the position where you will have what? Maximum force. This, if you have done that kind of water sliding and all, you will find minimum force. Now, this last one trick. Look at the number of ways you can answer this question. Everybody knows when a lift goes up with some acceleration, normal reaction increases. I hope you know that. And when lift comes down, normal reaction decreases. When it goes up, mg plus ma. It's coming from laws of motion. When it is coming down, mg minus ma. Look here. What is the acceleration? What is the direction of acceleration? Towards the center. That is up. As if lift is going up. So normal reaction will be what? mg plus this place, center. What is the direction of acceleration? Downwards. As if lift is coming down. So what is the normal reaction? mg minus. Automatically normal reaction is less. This, ये वो जगह है जहां पर लिफ्ट हमारे लिए कहां आ रही है? नीचे. ये वो जगह है जहां पर हमारे लिए लिफ्ट कहां जा रही है? ऊपर. तो यहां नॉर्मल रिएक्शन क्या होगी? ज्यादा. कंपेयर दीज टू. इस जगह पर एक्सेलरेशन कितना है v स्क्वायर बाय r सेंट्रीपिटल, यहां का भी कितना है v स्क्वायर बाय r, लेकिन यहां का r क्या है, यहां का r ज्यादा है। अगर r ज्यादा है तो सेंट्रीपिटल एक्सेलरेशन क्या होगा, कम, रेसिप्रोकल v स्क्वायर बाय r। You're saying that lift is going up with somewhat lesser acceleration as compared to this position, and therefore you can immediately compare between A and C, and you can say that at A normal reaction will be maximum. Could you understand, those of you who would not answer, do you understand any of the tricks, methods which I explained? If you understand any which way, write down yes in the comment box. Lift wise or feeling wise or जैसे भी आपके समझ में आया हो। This is question number 6, then question number 8. What is question number 8? Question 8 says, for a car taking a turn on a horizontal surface, let N1 and N2 be the normal reactions of the road on the inner and outer wheels. N1 is always greater than N2, N2 is always greater than N1, this, and that. Look here. Again, we'll answer the question without using maths. Feeling part. That means physics में you should get this kind of confidence that कि जरूरी नहीं कि आप equation and all इन सारी चीजों को use करो, थोड़ा सा observational power बढ़ानी है। Question क्या दिया है अपने को? There is a road, a circular turn, and this is the car. N1 and N2 be normal reactions of the road on the inner and outer wheels. Inner. This is the inner portion. This is the outer portion. N1 and N2. So car which is taking a circular turn, this is inner, this is outer. Question says N1 is always greater than N2, N2 is always greater than N1, N1 is always equal to N2, either A or B, depending on the speed of the car. We have a tractor, not a car, but a tractor, but purpose solve होगा अपना. This tractor, as it makes a circular turn, अगर मैं आपसे पूछता कि आपने जितनी भी movies and all देखी हैं, God forbid that you watch these things in real life, you don't want to, but if you have seen this type of sharp turn, just tell me कि किस तरह से ओवर टर्निंग होती है गाड़ियों की. Car, a careless driver, when he makes a very sharp turn, तो जो ओवर टर्निंग है, क्या आपने कभी किसी वीडियो या कहीं भी देखा है तो बताना, is of this type, that it comes inside or it goes out, in or out. Answer this way in the comment box. A car taking a sharp turn, it topples this way or it topples this way. I hope you can feel. अब इस actual setup में car taking a turn, ये अंदर की तरफ इस तरह से topple करेगी या बाहर की तरफ? What do you think, in or out? Well, that's why you guys find physics difficult. क्योंकि आपका इंट्यूशन ही खराब है. Everybody is saying in. I thought कि मैंने बहुत अच्छा ट्रैक्टर आपके लिए पकड़ा, लेकिन आप ट्रैक्टर के लायक नहीं थे. Everybody is saying कि it is going to come inside. कभी आपने रेसिंग एंड ऑल कार का जो दिखाते हैं वो सब नहीं देखा है कभी? फॉर्मूला 1 रेसेस एंड ऑल, व्हेन ड्राइवर लूजेस बैलेंस व्हाट हैपेंस? जो टायर्स होते हैं शॉक एब्जॉर्ब करने के लिए, हैव यू सीन दैट दोस टायर्स आर स्प्रेड along the wall, outer wall? Why? Because whenever accident happens, the car is going to overturn like this. It will never go inside. Never. कभी आपने साइकिल चलाई हो या मोटरसाइकिल, अगेन गॉड फॉरबिड, भगवान ना करे ऐसा हो, बट अगर स्पीड ज्यादा होती है तो आप उस बाइक के साथ या कार के साथ कहां स्लिप करते हैं? बाहर की तरफ. And that's what is sufficient to answer this question. Once you need to develop the feeling कि जब ये कार आएगी तो अगर sufficient centripetal force available नहीं है, then overturning will be like this. It will, if I could find a video of this, I will definitely send it to you. But for the time being, the moment you feel this, question is done. Inner tires ground के साथ contact खत्म हो रहा है. Truck, tractor, inner, outer, lifting. Lifting means inner tires का contact खत्म हो रहा है, which means N1 is less than N2. That's the answer. It's about feeling, which is very rare nowadays. Just tell me, those of you who initially wrote in, do you believe, did you understand that turning will not be like this, but turning will be like this? Now, as I have explained this thing, do you understand that turning, the way it should take place? That if you have a track, if you have a circular track, and this car makes a very sharp turn, then it's going to disbalance like this. Inner tires, they will lose what? Contact. As they lose contact, it means normal reaction becomes what? 0. So N1 is what? Less than N2. And for providing mathematical case, I will take some time, not in today's lecture, because I will have to explain the concept of torque and pseudo force. That will be a bit mathematical and you will find it not that comfortable. But once we are done with rotational motion and you are comfortable with things like centrifugal in circular motion, I will explain the mathematical origin behind n1 being less than n2. अभी के लिए मैंने केवल क्या दिया? Observational view. Observational view. I've given you this much only. आपको किसी कार या बाइक की जरूरत नहीं है. Do one thing. किसी कार की जरूरत नहीं, किसी बाइक की जरूरत नहीं. क्लास खत्म होने के बाद क्या करना? क्लास खत्म होने के बाद तेजी से दौड़ते हुए जाना and then make a sharp turn and feel कि आपका कौन सा पैर ग्राउंड से उड़ जाता है. Do this and you will find the answer. क्या बताया मैंने? दौड़ना, make a sharp turn, inner or outer, which one loses contact with the ground, feel it and answer the question. This question is something in examination room. If you find that you're not able to answer the question, start running, make a sharp turn, come back and answer the question. Next is question number 9. Ninth is a particle P is moving in a circle of radius A with a uniform speed v. C is the center of the circle and AP is the diameter. Angular velocity of P about A and C are in the ratio. So the question is, a particle P is moving in a circle of radius A or R, doesn't matter, they are saying A, let's take it R. This is P with a uniform speed V, speed is constant, C is the center of the circle, C is the center of the circle and AP is the diameter. AP is the diameter. Angular velocity of P about A and C. Angular velocity of P about A and C. They are looking for this ratio. Now this question is something which requires knowledge of geometry, which you have done in maybe 8th class. Let's see how many of you will answer this question of geometry. Look here. This is the center, radius, radius, radius. Object is moving this much, and let's say this angle is theta. This is theta. What is this angle? Who will tell me? If this is theta, what about this? Answer in the comment box fast. You cannot type theta, so simply write th. This is coming from the geometry part. Good. This is theta by 2. How come it's theta by 2? Simple geometry. This is external angle, which is sum of what? Internal ones. So let's call this angle alpha. Then this is also alpha. Why? This is R. This is also R. So it's an isosceles triangle, this one. And therefore these two angles are same. But this is the external angle, which is sum of these opposite internal angles. So your 2 alpha is theta and alpha is theta by 2, which is a standard result coming from geometry. Let's not waste time. This is your point A. What is omega about A? An observer at A finds that object is traveling from this position to this position. This is the initial position, this is the final position. The observer at A, what he finds, that object is moving from this to this, and how much angle does he cover? From this position to this position, for observer A, angle covered is what? Alpha, angular displacement divided by time. For an observer at C, same object, what is the angle covered? Theta divided by टाइम तो दोनों केस का सेम है भाई. ऑब्जेक्ट यहां से यहां मूव कर रहा है इन व्हाट टाइम t. ए को लगता है कि इसने अल्फा एंगल कवर किया, सी को लगता है कि थीटा. क्वेश्चन इज लुकिंग फॉर द रेशियो. डिवाइड. व्हाट इज दिस? अल्फा अपॉन थीटा. व्हाट इज अल्फा अपॉन थीटा? 1/2. That's the answer. Is there anyone who could answer this question? Anyone who could answer this question during the test paper? One, two, three. Only 3-4 people would answer this. So this was question number 9th. Now question number 11th. Question number 11 says a large mass capital M and a small mass small m hang at the two ends of a string that passes through a smooth tube as shown in the figure. The mass M moves around in a circular path which lies in the horizontal plane. Length of the string from the mass end to the top of the tube is L, and theta is the angle this length makes to the vertical. What should be the angular velocity of rotation of the mass M so that mass capital M remains stationary? भाई हमने जितना सर्कुलर मोशन किया था, जस्ट टेल मी फर्स्ट कि किस प्रोफाइल का यूज करना है अपने को. व्हाट इज द आर्टिकल व्हिच विल बी यूजफुल फॉर दिस क्वेश्चन. एटलीस्ट ये तो मालूम पड़े कि आप इतना ऑब्जर्वेशनल पावर रखते हैं या नहीं. फॉर दिस क्वेश्चन, व्हाट इज द आर्टिकल ऑफ सर्कुलर मोशन व्हिच वी डिड विल बी यूजफुल. And maybe you have answered by now. The answer is conical pendulum. So the question is something like this. You have a rope which has two parts like this. Now, if I want to make a cone, I hope you can see the cone being formed. If I want to make a cone, then either I need to hold this tight so that it doesn't slip. It doesn't slip. Or what I can do is, as it makes a conical pendulum, I simply hang a weight at this end. That means what? If a weight is hanging over here, then as this bob makes a cone, this thing keeps hold of it. It doesn't slide down. Question is all about this type of cone. And the setup they have given us is in this form. There is a tube through which this thread is running. अपने लिए अभी ऐसा ही है. This is theta. And what are the masses? Capital M is hanging and small m is there. This is capital M. And that's your small m. Which means this is mg. And this is capital mg. And rotation is with angular velocity omega, which they are asking. They have given theta, and they have also given us length. The length of the string from the mass m to the top of the tube is L. From this point to this point, this is L. And the question is looking for omega. If the angle means what should be the angle of rotation, mass m to the mass m means stationary. Now, I hope you understand the whole profile now. This m is moving in a circle, forming a cone, and just so that it doesn't come down, you're using this capital M. जैसा मैंने बताया. This place, as if I'm holding the object. This is making a cone. That's a cone being formed. And this part, this part is having the weight of mg. The moment you say this is capital mg, this is tension force T. But everything is balanced. It's not moving up and down. If it's not moving up and down, we immediately get T as mg. First thing, tension in a rope acts away from the body, T. This T is balancing mg. It's not going up and down, because this whole thing is maintained in the same horizontal plane. Tension in a massless rope at every point is same. So right here, tension is what? T. This is T. T बताया आपको. This T has a vertical component, this T has a horizontal component. It has a vertical component, it has a horizontal component. This is the center. This is the radius. Since we have already done this conical pendulum, let's do the thing calculation fast. This is theta, theta, theta. This is t. What is the vertical component? T cos theta. What is this component pointing towards the center? T sin theta. कोई बड़ी चीज नहीं है भाई. T थीटा पता है, वर्टिकल कंपोनेंट T cos, हॉरिजॉन्टल कंपोनेंट T sin. T cos थीटा, इसका क्या काम है? इस mg को बैलेंस करना. T cos थीटा क्या बैलेंस करेगा? mg. T sin थीटा ये क्या प्रोवाइड करेगा? Centripetal force, but they are looking for omega, and therefore use what? M R omega square. T sin theta, which is acting towards center, will provide what? Necessary centripetal force M R omega square. What is capital T? Mg. Here. Sin theta. M R. What is R? Question is दिया हुआ है. What is this? L. This angle is what? Theta. So you have a right angle triangle like this. L theta R. So what is R? R is the perpendicular component of L. L sin theta omega square. M R. This whole thing is R. Omega square. Sin cancelled. Omega square is coming M divided by M into G divided by L. So what is omega coming? Square root. Sin gone, capital M upon M, G by L. That's the answer. Is there anyone who would answer this question? One, two. There are two who could answer this. Good. All those who understand the question now, write down yes in the comment box. If you understand the question now, write down yes in the comment box. The working and all. Well, just tell me if you understand the trick for this question. There are four options given in the question. और ये जो ट्रिक पार्ट है इसको जरा केयरफुली देखना. Only two could answer this question, and therefore, if you understand the way tricks are applied, maybe without attempting all this, with the help of simple feeling part, I always use the concept. This is concept of feeling. जितना फीलिंग पार्ट ज़्यादा होगा फिजिक्स के साथ उतना, इनफैक्ट मैथ्स के साथ भी, मैथ्स में जितना विजुलाइज कर पाओ उतना इजी हो जाता है समझना. थोड़ी सी इस तरह की चीज़ों को आपके दिमाग में फिट करने की कोशिश करते हैं. देखना भाई यहाँ पर the options they have given us. The first option is root over capital M, small m, G by L. This is option A. Option B is small m upon capital M, G by L. देखना और कोशिश करना इस ट्रिक को समझने की. हम इस पर्टिकुलर ट्रिक में इंटरेस्टेड नहीं हैं, हम इंटरेस्टेड हैं ट्रिक्स को कैसे यूज करते हैं. एंड लास्ट इज G by L. And we need to find omega. Now, how many of you are comfortable with this, that C cannot be the correct answer? The moment you look at omega, which you need to answer, and you look at option C, you immediately know that C is not the correct one. If you understand this part, then write down yes in the comment box. What is the unit of omega? Radian per second. What is radian? Dimensionless. What do you get? 1 upon second. Mass upon mass, kg upon kg. The whole thing is completely dimensionless. Possible नहीं है. Possible है, possible है, possible है dimensionally. G, meter per second square. Meter, meter gone. 1 upon second square. Under the root 1 by second. 1 by second. At least out of 4 we have removed one option. कुछ भी हो जाए, अगर अपने को तुक्का लगाना है तो कम से कम C पर तो ना लगाएं भाई. That saves us. If you are making an unintelligent guess, then your chances of being correct are only 1 by 4. Out of 4, 1 is correct. 1 by 4, which is 25. बिना कुछ सोचे हुए. But if somebody thinks that C is not the possibility, then at least you have eliminated one option and you have improved your chances by 8%, 25 to 33. Well, at least कुछ तो अपने चांस बढ़ा दिए. Now, the next part is the option D is also not possible for this. It's dimensionally correct, लेकिन ये possible नहीं है. क्यों नहीं है? अगर मैं इस मास को इंक्रीज करूंगा कैपिटल M या स्मॉल m को इंक्रीज करूंगा तो फिर ये चीज डिसबैलेंस हो जाएगी. फिर से सुनना. फॉर अ पर्टिकुलर वैल्यू ऑफ दिस स्मॉल m एंड कैपिटल M, आपने देखा पूरा सिस्टम बैलेंस है और चीजें रोटेट कर रही हैं. फॉर गिवन सेटअप ये चीजें रोटेट कर रही थी. अब इस पूरे सेटअप में अगर मैं समहाउ इस मास को चेंज कर दूं, या इस मास को चेंज कर दूं. Suppose I made this thing heavy. If I make this thing heavy, it will be like this कि आपने इसे नीचे की तरफ खींचना शुरू कर दिया. So your omega, whatever it is, will definitely depend on what? These masses. Option D says there is no need of mass. हमने बोला भाई जरूरत है. You have to have mass also present in the value of omega. That eliminates D. ये थोड़ा सोचने वाला पार्ट था और इसी सोचने वाले पार्ट से अपने को A और B के बीच में आंसर मिलेगा. बताना मेरे को. इधर मैं इसे ओमेगा से रोटेट कर रहा हूं. These are the values of omega. We have to choose between A and B. A and B. Now it's your responsibility. You will try to answer this. थोड़ा फीलिंग पार्ट लेकर आना. इमेजिन कि आपने एक कोन को ओमेगा से रोटेट किया. कोनिकल पेंडुलम. You formed a conical pendulum. Now अगर मैं इसका ओमेगा ज्यादा कर दूंगा, if I increase the angular velocity, if I increase it, तो जो आप फोर्स लगा रहे हो उसको पकड़ने के लिए वो इंक्रीज होगा या डिक्रीज होगा? व्हाट इज योर फीलिंग? नॉर्मल फीलिंग. आपने क्या किया? आप सिंपल रोटेट कर रहे थे. देन यू स्टार्टेड रोटेटिंग इट विगरसली. इन विच केस यू विल अप्लाई फोर्स, मोर फोर्स. जैसे जैसे आप ओमेगा को इंक्रीज कर रहे हो, एज यू आर इंक्रीजिंग ओमेगा, आप फोर्स ज्यादा लगाओगे या कम? फोर्स विल इंक्रीज और डिक्रीज. आंसर दिस वे. इफ आई इंक्रीज ओमेगा, the force which I need to use to hold the whole thing that will increase or decrease. Simple logic, and logic is correct. It will increase. इसमें कहीं कोई लॉजिकल चीज ही नहीं है. रोटेट करो, ज्यादा फोर्स लगाओ, और ज्यादा रोटेट करोगे और ज्यादा फोर्स लगाओ. दैट मीन्स यहां जो एक काम था इसको रोकने का, ये मेरे हाथ ने किया कि मैंने ओमेगा को बढ़ाया. किसने संभाला? मेरे हाथ ने. यहां कौन संभाल रहा है? कैपिटल एम. तो जैसे जैसे आप ओमेगा को इंक्रीज करोगे वैसे वैसे इसको स्लिप होने से रोकने के लिए आपको ज्यादा फोर्स लगाना होगा. Which means आपको कैपिटल एम को क्या करना होगा? इंक्रीज. That's the answer. Omega is proportional to capital M. This says omega is proportional to small m. It's not correct. That's the correct answer. This is a trick part. अब ये फीलिंग वाला पार्ट, ट्रिक वाला पार्ट, ये क्या दो क्वेश्चंस को करके आ जाए ऐसा भी नहीं है. You need to solve at least 200 questions of a given chapter and then you will start developing these feelings. How many of you understand the trick? If you understand the trick, write down yes. If you do not, write down no. There is no shame if you don't understand it. अभी आप लर्निंग प्रोसेस में, हो सकता है कि आपको समझ में नहीं आई हो. You can simply write no. This was question number 11th. Now we need to answer 12th. There are so many questions. 12th. Speed up the whole thing. 12th question is an electric fan has blades of length 30 centimeter as measured from the axis of rotation. The fan is rotating at 1200 rounds per meter per minute. The acceleration of a point on the tip of the blade is about. Why are you asking these questions? Question number 12th. This is our, they have given us omega. What is omega? 1200 rounds per minute. 1200 RPM. Blades of length 30 centimeter. R is 30 centimeter. Acceleration of a point on the tip of the blade. What is the acceleration of this point? They have given us omega. There is no change in omega. If there is no change in omega, only acceleration you have is what? Centripetal. What is centripetal acceleration? R omega square. R omega square. What is R? 30 centimeter, that is 0.30. What is omega? It's not 1200. What is 1200 rounds per minute? This 1200, and जानबूझ के omega करके लिखा. But what is the unit of omega? Radians per second. What is this? Rounds per minute. एक तो चीज मिनट को चेंज करना है. दूसरा round. What do you mean by round? When you make one round, how much angle you cover? 2 pi. तो ये जो 1200 है, ये basically क्या है? F. What is F called? Frequency. Frequency means number of repetitions. In 1 minute, how many repetitions? 1200 repetitions in 1 minute. So you have an object which is making 1200 rounds. And for every round, the angle covered is what? 2 pi. इसका मतलब ओमेगा आपको मिल गया. हमारा जो ओमेगा है वो आ जाएगा remember this also, omega is 2 pi f. Remember this formula. What is the formula? What is f? Frequency. Just to अभी क्या अगर मैं यहाँ से ओमेगा हटा दूँ, this is the frequency curve. ओमेगा इसके साथ associate कर दिया है. So what is this? If you make one round, what is the angle covered? 1 into 2 pi. If you make 5 rounds, 5 into 2 pi. So if you make f rounds, what is the angle covered? F into 2 pi. That gives you omega. So for us, omega is coming what? 2 pi. Frequency is 1200 per minute. 60. Use this omega, put it here, square, multiplied by 0.30, 0.30, and you will get your answer. All those who could solve this question, write down yours in the comment box. This is question number 12th, and then 14th. 14th is 3 small balls, each of mass 100 grams, are attached at distances of 1, 2, and 3 from the center, which is at end D of a 3 meter long string. The string is rotated with uniform angular velocity in a horizontal plane about D. The outside ball is moving at speed of 6 meters per second. The ratio of tension in 3 parts of the string will be. For question number 14, I will send you a lecture which I have already prepared. It will give you the method and will give you a beautiful trick. So I'm not going to discuss 14 in the class. For 14, after the class, I will send you a useful, important 10-second trick. The lecture which you are going to see is of around 10-15 minutes. I don't remember exactly the time. But the trick involved, once you understand that, takes only 10 seconds. So I'm not wasting time in question number 14. You will get the video link. 14th, then 15th. 15th is the block of mass m is placed on a smooth wedge of inclination theta. Whole system is accelerated horizontally so that block doesn't slip on the wedge. Force exerted by the wedge on the block has a magnitude of, this is coming from laws of motion, and those of you who have seen lectures on motion of an object on an inclined surface, we have already done this exactly the same question. Let's answer the question first. Then coming, the question says again, is a block of mass m which is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that block doesn't slip on the wedge. The force exerted by the wedge on the block. Look here, you have a triangular wedge. This angle is theta. Small m. Downward force is mg. This force is normal reaction n. You have a wedge, my hand, which makes an angle of theta with horizontal. This is a block of mass m. If everything is frictionless, you know that it will come down. It slip kar jayega niche. But question says you're accelerating the wedge, and in this process, it doesn't come down. The block doesn't slip, and they're looking for force. They're looking for force exerted on the block by the wedge. This force. They're looking for n. क्या करना था? ये करना था भाई. This is theta. This is theta. Geometry. लॉज ऑफ मोशन में किया है, जाकर देख लेना. This is theta. Alternate angle. What is component of n in this direction? N cos. ये जो n cos है ये ऊपर लग रहा है और mg कहाँ लग रहा है? नीचे. और स्मॉल m स्लिप नहीं कर रहा. स्लिप नहीं कर रहा है मतलब नीचे नहीं आ रहा है. इसका मतलब n cos किसे बैलेंस कर रहा है? mg को. That's all. N cos theta is mg. N is coming mg upon cos theta. Done. Last, फिर से normal reaction इधर लगा. This component of normal reaction is n cos theta. N cos theta is balancing mg, and therefore this thing is moving only horizontally. What is that which is making the horizontal motion possible? Horizontal component of n, which is n cos theta, n sin theta. लेकिन अपने को जरूरत नहीं है उसकी. आगे क्यों जा रहा है? इसकी वजह से. ऊपर नीचे क्यों नहीं जा रहा? इसकी वजह से. n is coming mg upon cos theta. Option B. How many of you will answer this question? Write down fast in the comment box. After 15th is 18th, 18, 20, 21. 18th is in a certain machine at a fun fair, a man stands against the wall of a circular room of radius r. The room rotates about a vertical axis through the center of the floor with an angular velocity of omega radians per second. Then the floor is lowered, the man doesn't slip vertically downwards. Least value of the coefficient of friction between the man and the wall. Imagine this setup. You have a large cylinder. This is the axis. This radius is r, and cylinder is rotating with angular velocity omega. And what you did? There is an object of mass m. Question के हिसाब से कोई आदमी है भाई अंदर. And so this thing is not sliding down. Coefficient of friction between the walls in this block is what? Mu. तो किस तरह का question बना हुआ है? Try to feel कि this is the object. If you hold the cylinder, assume my arms, they're like a cylinder. If you hold the thing at rest, it will simply slide down because of gravity. But if the whole thing rotates, if the cylinder rotates along with this block, then what is going to happen? This block for rotation will require what? Centripetal force. Centripetal force किधर लगता है? Towards the center. ये लगा. This is normal reaction. लेकिन ये इधर क्यों लग रहा है? ये भी दिख रहा है. You need a centripetal force. mg cannot help you in that regard because mg is acting downwards. This is the direction of normal reaction. Normal reaction इधर क्यों आया? Normal reaction is a pushing force. Push. जो walls हैं सिलेंडर की, उसको क्या करेंगी? Push with the cylinder as it rotates. It's being pushed against the wall. N. So this N is something which is going to give you what? Necessary centripetal force. mg cannot. किसी भी वेक्टर का अपने से 90 पर कोई इफेक्ट नहीं होता. तो फिर n क्या करेगा? इस n ने बोला कि भाई हम ये कर देंगे. I'll give you m r omega square. बहुत सही. अब what is this mg? इसको नीचे स्लिप करने के लिए कौन रोकेगा? fr. कौन? fr. fr आपको पता है is always less than or equal to mu n. अपन क्या बोलते थे? अपन बोलते थे मैक्सिमम ऑफ fr. फ्रिक्शन का मैक्सिमम क्या होता है? mu n. Which means what? कि fr किससे कम होता है? mu n से. If fr is less than mu n, which means you're saying fr is less than what? Mu n. What is n? m r omega square. But question says this block is not falling down, it's not slipping down. If it's not coming down, then fr is balancing what? mg. fr is balancing what? mg. Done. M and cancel. Question is looking for, I don't know what, the least value of the coefficient of friction between the man and the wall. They're looking for mu. This gives you mu should be greater than or equal to m cancel g upon r omega square. Mu should be greater than or equal to g upon r omega square, which means what? This is the minimum value of mu. Mu इससे ज्यादा होना चाहिए. फिर से हुआ क्या था? इस ऑब्जेक्ट को सर्कुलर मोशन करने के लिए चाहिए सेंट्रीपिटल फोर्स. किसने दिया? नॉर्मल रिएक्शन ने. जैसे ही नॉर्मल रिएक्शन आया, फ्रिक्शन की मैक्सिमम वैल्यू डिसाइड हो गई. mu n. It's not mu mg, it's mu n. ये जो फ्रिक्शन है किसको बैलेंस कर रहा है, mg को। हमारा फ्रिक्शन हमेशा किससे कम होता है, अपनी मैक्सिमम वैल्यू से, विच इज म्यू एन। बॉडी नीचे नहीं आ रही है, वेट बैलेंस किया, that gives you mu. Is there anyone who would answer this question? Write down yes. I'll take just 2 more minutes for the next 2 questions. They're very easy. We can solve them in just 2 minutes time. Twentieth is there is a rubber band of length L, has a stone of mass n tied to the one end. It's whirled with speed v so that stone describes horizontal circular path. Tension T in the rubber band is. This is a rubber band. There is an object which is moving with speed v. Length of the rubber band is L. Length L has a stone of mass. This is the tension of the T. Now, this is a rubber band, which is like a string. What difference does it make? This is the natural length, and the moment you move the object with speed v, this rubber band is going to stretch. So instead of moving in a circle of radius L, this thing is going to move in a larger radius circle. So this radius is R, which is greater than L. R is greater than L. इस पर इस तरफ क्या लग रहा होगा, T. स्प्रिंग जब खिंचती है तो उसके अंदर क्या डेवलप होता है, रीस्टोरिंग फोर्स। और ये T क्या प्रोवाइड करेगा, सेंट्रीपिटल फोर्स। व्हाट इज दैट, mv स्क्वायर अपॉन r। अभी तक कोई खतरनाक चीज नहीं है। ये रबर बैंड थी, जैसे ही रोटेट किया स्ट्रेचिंग की वजह से लेंथ बढ़ गई, रेडियस इज ग्रेटर देन l। टेंशन क्या होगी, इट विल प्रोवाइड सेंट्रीपिटल फोर्स व्हिच इज mv स्क्वायर अपॉन r। द क्वेश्चन सेज टेंशन T इन द रबर बैंड इज 0। नो, सामने है। सेकंड ऑप्शन सेज mv स्क्वायर अपॉन l। नो, greater than mv square upon L or less than mv square upon L. This is mv square upon R. ये R क्या है अपना, L से ज्यादा। C option is saying that, let's remove this. C option says T is greater than mv square upon L. And D option says T is less than mv square upon L. भाई T है कितना, R. What is R? Greater than L. तो ये जो चीज है mv square upon R, ये R आपका क्या है, L से ज्यादा है। डिनोमिनेटर आपने बढ़ा रखा है, इसका मतलब टेंशन क्या होगा, mv square upon L से क्या हो जाएगा, कम हो जाएगा। So this is how you answer this. This is mv square upon R, and this mv square upon R, which is समझ में आ गया होगा, easy है। This is 20th. Is there anyone who could answer this question? If you could, write down yes in the comment box. Last question. A racing car is traveling along a track at a constant speed of 40. A TV cameraman is recording the event from a distance of 30 meters directly away from the track as shown in the figure. In order to keep the car in position shown the angle. Let me give you the feeling. Not the feeling, exact method. It will take just 30 seconds for me to answer. Rest, it depends on you. V theta camera. देखना इधर. This object is coming in this direction. This angle is theta. यहां पर एक आदमी है और ऑब्जेक्ट इधर आ रहा है. They have given us this distance is r. I mean, they have given this distance as 30, and they are looking for angular velocity. But the question is, there is a cameraman over here, and an athlete is moving in this direction. So the camera is throughout aiming the athlete. As the athlete moves, camera keeps on turning so that athlete is all the time in the view of its lens, and they are looking for angular velocity required for this. अब इस तरह के क्वेश्चंस के लिए एक छोटी सी कहानी है. बस छोटी सी कहानी क्या है? दिस इज थीटा. अगर ये थीटा है, this is 90. This angle is also theta. Theta 90 minus theta. क्यों बनाया सामने? ये जो v है, this component is v cos theta. This component is v sin theta. I hope you can see the blue marker. Yes, you can. Intentionally हमने इस v के दो कंपोनेंट कर दिए, v cos and v sin. Now थोड़ी देर के लिए v sin से बात करते हैं. आप यहां पर खड़े हुए हो, forget about v cos. An object is coming towards the camera with v sin. ये ऐसे आ रहा है. Is there any angular velocity involved? You're holding the camera like this, an object is moving towards you. Do you need to rotate your camera? No. Which means ये जो v sin theta है, इसका ओमेगा में contribution क्या है? 0. I hope you understand this part. And once you understand this part, question is done. Question क्या बोल रहा है कि इस ऑब्जेक्ट के लिए एंगुलर वेलोसिटी केवल कौन डेवलप करेगा? This is v cos theta component. Let's call it r. Here lies your camera. v sin बोलता है कि मेरे से एंगुलर वेलोसिटी नहीं आएगी, v cos आएगी. अब आपको पता है सर्कुलर मोशन में हमने क्या सीखा हुआ है? v इक्वल्स टू आर ओमेगा. लेकिन यहां पर जो v है, ये पूरा का पूरा ओमेगा में इन्वॉल्व नहीं है. दिस कंपोनेंट says omega is 0. What is the other component? v cos theta. So in this v equals to r omega, which component is giving us angular velocity v cos theta? R omega. The omega is because of v cos. They are looking for angular speed. Find out omega. What is omega coming? Omega is coming v cos theta divided by r. This is r. This is 30. You can see that this r is 30 upon cos theta. This upon this is cos theta. Simple geometry. This upon this is cos theta. This is known. So what is r? 30 upon cos theta. Put 30 upon cos theta. You have the value of v. They have given the value of v. They have given us the value of theta. Put all those values. Cos will become cos square. Cancel nahi ho raha hai. It is becoming cos square. Solve it and you will get the answer. Theme क्या थी? इस तरह के क्वेश्चंस में this is called radial component. ये जो रेडियल कंपोनेंट है, जो कैमरे की तरफ आ रहा है, इसका एंगुलर वेलोसिटी में कोई कंट्रीब्यूशन नहीं होता. क्यों नहीं होता? मैंने बता दिया कि कोई आपकी तरफ चला आ रहा है, अगर कोई चीज आपकी तरफ आ रही है तो आपको अपने सिर को रोटेट करने की जरूरत नहीं है. You need to rotate it because of this component. So in V equals to R omega, this V equals to R omega was developed for this type of circular motion, जहां पर V और रेडियस के बीच का एंगल क्या था? 90. V और R. तो किस V और R के बीच का एंगल 90 है? V cos और R. Note down this much and then you can leave. Thank you very much.